Okay, everybody, this is chapter 12, section 3. We're still working with circles. We're going to be dealing with angles and arcs in this particular section. This one's a little bit different from the last one that we did that kind of goes with section 1 from this chapter. So just you got to make sure that you got these vocabs down and understand the rules that go with them, okay? So make sure you study these. Go back over your notes, all right? So you got two definitions up here at the top. One's an inscribed angle, and so that one is an angle with the vertex on the circle. Okay, so that if we use this this picture over here, the vertex is on the circle, okay, and it creates an angle. So let me move this guy back. Right, so it created an angle, but its vertex is on the circle, okay? Also, when you create that angle, you've created an arc. So you're going to have an arc that the angle hits. So the two rays that create the angle have now created an arc because it's intercepting the circle, okay? So you have an angle, and then that also then creates an arc. Okay, so remember that arc is part of the circle, all right? So we come down here to this box, theorem 12.11, and it says, if an angle is inscribed in a circle, then its measure is half the measure of its intercepted arc. So let's kind of write that out in kind of a math form. So my angle is going to be equal to the arc divided by 2. Okay, so that's basically what that theorem is saying. So if you have an arc and you want to use that to get the angle measure, you're going to take the arc divided by 2. That gets you the angle. Okay. Now what happens is that we play games with that. We can take this rule and we can turn it around. If I have an angle and I can use that now to find the arc, but now I've got to double the angle to get the arc. So we could play, games with that. So if you want to, we could write this out as the arc is equal to 2 times the angle, whatever that angle might be, okay? So let's use that to kind of do some of these down here. Example 1, they're giving me the angle, but they want me to find the arc. Okay, so if you kind of go back to those rules, I have the angle. I need to get the arc, so I think I have to double the angle to get the arc. So I'm going to double 37. When I do that, I think I get 74 degrees. And let's see what the balloon says. And we do get 74 degrees, okay? So that's fine, kind of playing games with the theorem they give me. If I have the angle here again, it's 112 degrees. So therefore, what I want to do then is if I want to use that to get the arc, okay? So if I use that formula again, I want to double the angle to get the arc. So if I double 112, I believe I get 224. And let's see what the balloon says. And I do get 224 degrees, okay? So once you try this last one, that angle, I believe that tells me it's 90. And if I double that, what do you get? And I think I'm going to get 180. And the balloon says 180 degrees. Okay, now I'm going to take this one step further. If I have that angle being 90 and it's intercepting the circle and creating this arc, and if that arc's 180, then that should tell me that this line that I draw right here should be a diameter, and therefore it has to be going through the circle or through the center of the circle if it's 180. Okay, so there you go on those. All right. So now we're going to actually go to what the theorem says. If you have the arc, the angle should be half of that. So now what I'm going to do is if I have that, this is actually indicating the measure of this arc. So I really want to go ahead and divide that by 2. Okay. So that should get me then, I believe it gets me 55 degrees. And let's see what the balloon says. And we were correct, okay? So if you go to section B here, or example B, this line is actually going through the center of the circle. That's what that point is there, okay? So if it's going through the center, that tells me that AC is a diameter, and therefore this arc right here is going to be 180. And this arc right here is created by the angle ABC. So if I have the arc as 180, I go back, you know, I'm supposed to get the angle, I have to take the arc and divide it by 2, right? So angle B, or angle ABC, should be 90 degrees, okay? But I can use that relationship of that dotted line there going through the center and connecting AC created a diameter, and we know that, you know, half of a circle is going to be 180. Okay, so you could use different ways to figure that one out. So let's see what the balloon says, see if all that talk got us the right answer, and it did. Okay, this last section, C here, I'm going to actually come down and do this corollary to 1211. It says if 2 inscribed angles of a circle intercept the same arc, then the angles are congruent. So if you kind of look at this, I'll do this in different colors here. I've got an angle right here, you know, angle D right there in black. And then I come over here and I have this other angle, angle C in red. Those 2 angles, you know, intercept the circle at different points, but they are intercepting the circle at the same arc, and that's arc AB. Okay, so that theorem, or corollary to the theorem, is saying if you got 2 different angles but they intercept the same arc, then those angles have to be the same. So let's kind of just write that out. Angle ACB is going to be congruent to angle ADB. Okay, very good there. So now let's take the theorem here, or what they gave me here. They told me up here for C that arc AB is 72 degrees. And they want me to find these 2 separate angles. Well, if you go back to the original theorem, the arc is going to be double what the angle is, or the angle is going to be half of the arc. So if they gave me the arc, I'm going to want to divide that by 2, and that's going to get me 36 degrees. Okay. Now, going back down to this corollary, if 2 different angles create the same arc, then the angles have to be the same. So ACB should be 36 degrees, and so should ADB. Okay, now that's a test question right there. You will see that again. Not too difficult. They created the same thing, so therefore that kind of makes sense. They have to be the same. Okay. All right. Move on here. An inscribed polygon. It's just a polygon. I don't think it's up there. I'll have to write that, so sorry for my writing. An inscribed polygon is just a polygon inside a circle. So basically all the vertices of a polygon, so that could be a triangle, it could be a square, it could be octagon, whatever. All the vertices touch the circles at different points, okay? All right, if you have a right triangle inscribed in the circle, so the hypotenuse of that right triangle is going to be the diameter of the circle. So let's just draw this. I'm going to draw a diameter, okay? But that diameter now is the hypotenuse of a right triangle. So let's just kind of sketch it in a right triangle. Looks something like that. And let's show that it's right, okay? So if you have any part of a triangle that goes through the diameter, that diameter becomes a hypotenuse of any kind of right triangle. So that could be drawn lots of different ways, but there you go, okay? This next corollary, a quadrilateral, so a four-sided figure can be inscribed in a circle if and only if, oh my gosh, that's from a long time ago, if its opposite angles are supplementary. So remember, supplementary is 180 degrees, two angles that add up to that. In this case, too, another important term is opposite. So they kind of give you the supplementary angles theorem over here. But E and D are opposites, okay? So we got to take those two opposites. If I add them together and equal 180, then that quadrilateral is inscribed in a circle, and it has to be for both. So there's another set of opposite angles here, F and G. They also have to add up to 180 for a quadrilateral to be in that, okay? So I'm going to skip to part B here first. We're going to kind of use that theorem a little bit and do B first because I think it's just kind of a little bit more clear, I hope. And then we'll do A. So they say that opposite angles, so I'm going to say that X and 100 are opposite, have to be supplementary. And therefore they want me to solve it for X. So, well, I'm going to subtract 100 from both sides. I'm going to get X is 80, okay? They also, I need to make sure that these opposite angles are going to be supplementary. So they want me to solve it for Y to prove that. So I'm going to do the same thing. I'm going to add them together, they equal 180. And then I'll solve that for Y. So I'll let you guys go ahead and do that. Okay, so if you do all the math there, you should get Y is equal to 20, okay? All right, pretty good. All right, going back to, now let's do example A. One thing that we know that a triangle has to equal 180, but my problem is that I got two different variables. I got X and Y, and I can't really solve it with two different variables, okay? And this triangle is not drawn really great. It's all these vertices should be touching the circle, and they're not, okay? But one thing that I'm going to take a clue is that, hey, that line right there, or that side of the triangle is actually going through the diameter. If I go back up to the other corollary, if a part of the triangle is a line through the diameter, then it has to be the hypotenuse. Well, if it's doing that, then that tells me this is a right triangle, okay? So therefore, the side opposite, or the angle opposite the hypotenuse, has to be right. So that's telling me that X is equal to 90. So using some rules that we know, some rules that we just found, or we're told, we can kind of use that. So X is going to be 90 by that rule. A triangle is still going to be 180, so I can take the 90 I just found, the 40 that they gave me, and they want me to get Y. I can do that, okay? So if I solve that, 90 and 40 is 130. I subtract that from both sides. I'm going to get that Y is 50 degrees, okay? All right, so that's a test question right there. It's a recognition, hey, part of the triangle is going through the diameter, therefore it's the hypotenuse of a right triangle. That will help me find one of the angles is 90, and I'm pretty much good to go there, okay? All right, this last question, we're throwing some algebra at you, so this one gets a little bit tough. I'm taking the rules that I just found that if I have a quadrilateral and it's inscribed, then the opposite angles need to be supplementary. So I'm going to take 5x and 2y are supplementary, so equals 180. The same rule applies for these other two angles or opposites. So I can take that and set them equal to 180, okay? Well, that's not really helping me. I'm not really getting that. It's not something I can really solve, okay? But if you guys are really good with your algebra, and I know it's been maybe a while since we've done a little bit of algebra review that deals with this, I've got a system of equations, and this system of equations is set up for elimination, okay? So hopefully that rings a bell a little bit and can get us going. Now remember, with elimination, you got choices. You can kind of do things however you want. For elimination, I want to get rid of the x or I want to get rid of the y. It's your choice, okay? I'm gonna choose to get rid of the y's just because it's going to be smaller, maybe a little bit easier to do. So what I want to do is I want to get the y's to be the same value, but I also then need to make one of them negative, okay? I'm going to choose, and once again, it's your choice, but I'm going to choose to get the top to be negative, and I'll leave the bottom y positive, okay? Both 2 and 3 go into 6, so 2 goes into 6 3 times, but like I said, I'm going to make it negative, so I'll make it -3. And the bottom y, 3 goes into 6 twice, so I'm going to multiply this whole thing by 2. So once again, I'm just going to warn you, you can do this different ways. This is the way I chose to do this. You could have chose a different way, all right? So I'm going to go ahead and distribute that -3 through the top. Remember, you got to do it to everything in the top. And then on the bottom one, I'm going to distribute that 2 through, so I get this. Okay, and then I want to just basically add everything vertically. So here, the x's, I'm going to get a -9x. Here, the y's will eliminate. And down here at the bottom, -540 and +360 give me a -180. Okay? So hopefully, you know, the system stuff is coming back to you. I'm going to go ahead and solve it for x. I'm going to get a -9 and divide it both sides. And I'm going to get x is equal to +20. Okay? Now remember, with systems too, though, I got 2 different variables. I need to solve them. I need to solve for both of them. So I have to take this x equals 20, and I got to go back and plug it into one of the original equations to solve it for y. Once again, you got a choice here. You can plug it in wherever you want. It doesn't really matter. I'm just going to do it to the top. So I'm going to plug 20 in for x. I'm going to go ahead and solve that. 5 times 20 is 100. And I'm going to subtract 100 from both sides. And I'll go ahead and divide by 2. Y is 40. Okay, so I've got 2 solutions there for my variables, but I want to use that to check to make sure this all works. So I'm going to go back to my picture and plug these in. X was 20. So down here, 3 times 20 is going to get me 60. Over here, 5 times 20 is going to get me 100. Okay. I got y is 40, so I'm going to go up to the top. 2 times 40 is going to get me 80. and 3 times 40 is going to get me 120, okay? So once again, look at your opposite angles. Are they supplementary? 120 and 60 is supplementary. 80 and 100 is supplementary. So therefore, I got the correct values for those two, okay? So just taking that rule and kind of applying some algebra to it and be able to kind of see if you can do that, all right? Okay, let's move on. We've got a theorem here. It's very similar to the one that we had earlier. This is kind of a different angle that's inscribed on the circle. A is the vertex. It's on the circle, but I want you to understand something here. The way this angle is drawn is a little bit different, but it's actually this line right here is a straight line. It's actually creating two different angles, okay? So let's look at that first. And remember, a line's going to be 180 degrees. Sometimes that will help us a little bit with what we're going to have to do down the road, all right? But the theorem over here has the angle is once again going to be half of the intercepted arc, and that's what we just did, except the angle was drawn a little bit differently. I'll do it off to the side just so you can make a context here. Remember, we kind of dealt with that where the vertex is right here, and we really did intercept an arc, okay? This is the same thing, it's just a little bit different, okay? So I still am intercepting an arc. I'm intercepting the arc, the circle arc AB, and I'm intercepting a bigger arc. It's ACB or BCA, whichever way. So I'm really getting the whole circle from those two arcs the way that this one's drawn, okay? But I want you to get that the formula right here and right here is the same thing that we did earlier, okay? So it's just drawn differently, okay? So if you have an angle, you want to double it once again to get the arc. If you have an arc, then you want to cut it in half to get the angle, all right? So identify what we got here. I got this arc right here, so I want to get this angle right there. So if I have the arc, I cut it in half to get the angle. So that's going to be 75 degrees, okay? Let me just kind of use this kind of illustrate something else. That's 150 degrees of the circle. So I subtract that from 360. That gets me that this is 210 degrees, okay? So 210 plus 150 is 360. And remember, this is a straight line, it's 180. So if I already got one angle at 75, can I get this other angle over here? Well, 180 minus 75 is 105. Okay? And if I double 105, do I get 210? Or if I take 210 and cut it in half, do I get 105? So we're gonna mess with you guys on stuff like that, taking some rules that you learned to be able to kind of apply that, okay? So they want it on this example B, they want the arc RSP. Well, I've got the angle that's creating that arc. So therefore, I think I'm supposed to take that angle and double it. So I double 130, what do you get? I get 260 degrees. I'll put it up here for that arc, okay? Well, guys and ladies, don't I have another arc over here? And this big arc was 360, so if I take 360 and subtract the arc that I have, what's this little guy going to be down here? Well, I think it's going to be 100, okay? Right? And if that arc is 100 degrees, how do I get this angle down here at the bottom? Well, I take the arc and cut it in half. I get that angle is going to be 50 degrees. Well, isn't 50 plus 130 that straight line, okay? So we want to be able to kind of mess with this one pretty well, all right? All right, let's go over here. Let's label this in C. Angle ABC is 64 degrees. And they want me to get arc ADB. And they tell me that it's 4x plus 10. Oh my gosh, I'm not sure what I'm supposed to do with this, okay? But let's think of this. And there's different ways I could do this problem too, okay? If I take this angle right here is 164, and I know this is a straight line, and this arc ADB is being intercepted by the angle AB, or just angle B. You could take that 64, subtract it from 180, and I believe I get 116. Can't I then double that to get this arc up here? Well, that's what the rule's been telling us, and we kind of use that to play games over here with the first two. So if I double 116, I think I get 232 degrees. Well, if that 232 degrees represents that arc, can't I set it equal to what they told me the arc was and solve it for x? Okay, because they don't say that, but they want me to solve for x. Okay, so what I'm going to do is I'm going to take that and set it equal to 232. Okay, so I'll let you guys go ahead and solve that. And you should get a decimal answer for that. So x equals 55.5 degrees. Okay, so that's one way you could have done that. And just using a straight line. Remember, we did that, like, I think we do that in August with you guys. I use that to kind of help me get that. Okay. Another way I could have done it, this 64 degrees was the angle. I could have doubled that. I get 128 for this arc. And I could have taken that and subtracted it from 360. That would have given me 232. But I still had to go back and set it equal to 4x plus 10 to solve for it. Okay. There's another way to do it, but I think those are the two pretty kind of obvious ways you could have attacked that one. Okay. All right. So there's a lot there, but it's pretty much all connected using some stuff. We did throw some algebra at you that took some time. But just kind of, we need to do that occasionally to keep you guys on your toes. Okay. All right. Thank you.